This is Pre-Calculus, Unit 3, Trigonometric Identities and Applications, Lesson 4. I'm actually going to combine Lessons 4 and 5 kind of together because it's law of sines and law of cosines, and the subject really is solving triangles that are not right triangles. When you solve a right triangle, you can use special right triangles like the 30, 60, 90 triangle, the 45, 45, 90 triangle, or if they are not those special angles, you can use the trig ratios, sine, cosine, and tangent, using the mnemonic SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. When it comes to non-right triangles, none of those will work. And so we have two rules, two laws that we use, the law of sines and the law of cosines. And in this video, I'm going to explain the origins or where the law of sines comes from. Okay? And so I'm going to draw a non-right triangle. Now, the proof is a little different depending on whether or not we draw an obtuse triangle or an acute triangle. I'm going to draw, an obtuse triangle changes things a little bit. I'm going to draw an acute triangle here. Rather than an obtuse. Okay. But it really actually does transfer to all triangles. So, okay. So here's our triangle. I'm going to label this A, B, and C. And I'm going to draw the altitude from C. And we will label that H. Okay, so the altitude from C is H for height. All right. Okay. Now let's label with lowercase letters the sides. The side opposite cap A is lowercase a. The side opposite cap C is lowercase c, which is not going to be used in this explanation. The side opposite angle B is lowercase b. Okay. All right. And let's look at a pair of triangles. So I'm going to look at the right triangle formed by angle A and the height. Okay, so let's sketch that here. So we've got this right triangle right here. And here. Okay. And I want to examine the sine of angle A. The sine of angle A. Okay. So that's a right triangle. So SOHCAHTOA works. Sine. Opposite over hypotenuse. The opposite is H. Hypotenuse is B. Okay. Now rearranging or multiplying both sides by B ends up with H equals B sine A. Okay, and we're going to stop right there and keep that result. Okay, now I want to look at another right triangle, the right triangle formed by angle B and the height and the altitude. Okay, so here we go. Angle B right here. Also a right triangle. So sine of B is opposite H over hypotenuse A. Multiply both sides by A and we find that H equals A sine B. Okay. Now together I can put these two things together this way. When two things are equal to the same thing, both B sine A is equal to H and A sine B is equal to H, by the transitive property, that is, two things being equal to the same thing, they are equal to each other. So B sine A equals A sine B. Okay? And now I'm going to divide by AB. Divide both sides by AB. That's using the division property of equality. Here the A's cancel, and here the B's cancel. Okay, and we end up with sine A over A equals sine B over B. Okay. Now, since the choice of A and B was arbitrary, we can really extend this to prove also that sine C over C is included in this, but I'm going to leave that for you to explore. And this is the law of sines. So the law of sines is essentially saying that the sine of an angle divided by the opposite side is consistent. Okay? The ratio of the sine of an angle in a triangle to its opposite side is constant. It's always the same thing for any given triangle. Now, this does not say that between two different triangles this ratio is the same, but in any triangle this ratio is the same. Okay? And this can be used, this is true of all triangles, whether they're right triangles or not. Okay? And I'm going to leave using this rule for a later recording.